All right. Well, it is 10 o'clock, and I want to welcome you to today's workshop with Scott Sanders of Condor Earth Technologies. They're a great firm that has several offices throughout the Central Valley. Scott is out of the Rancho Cordova office, and he is a senior environmental specialist and also a QSP and QSD, a CPESC, and someone who has a lot of experience with the construction general permit. So we're glad you can be here. He's going to be talking about a subject that's near and dear to my heart. So I'm really looking forward to hearing about this and all sorts of mishaps that happen with the CGP. Sometimes it can get actually quite comical, right, Scott?
Yes, it can.
So, all right. Well, Scott, I'm going to let you take it from here, and I'll just bring people in as they come in.
All right. Thank you, John. Well, welcome to Water Flows Uphill. As you said, I'm Scott Sanders. Thank you for taking the time out of your days to join me in this presentation. And a little forward, what we got here going is our agenda. I'm going to do a little bit about me, a little extra on what John said. We're going to go over the new permit guidelines. If this is new to you, we have a new permit for the construction general permit just adopted this September. We'll go over some main points that I want to talk about. BMP 101, this was the whole water flows uphill. Things that I see, things that I had colleagues send me that we just thought were common sense, but things that I feel I should bring out just to get everyone on the same page. And then we're going to go into some technology and stormwater that just helps all our lives a little better. And then I'm going into a little sampling. I added that because of the new permit guidelines and those TNDLs. You might have to do a lot more sampling. So I thought a good refresher course maybe for some people just to get your feet a little wet. And that's how we're going to end the presentation. So about me at Condor Earth Technologies, that's where I work. We're an environmental and stormwater consulting firm. We work with the construction permit, the industrial permit, the municipal permits. We're a geotechnical engineering firm with materials testing, SPCC plans, industrial compliance. We do it all. And there I'm a senior environmental specialist. I'm a QSD, CPES, SESWI, and right there at the end, I'm a SORI too. I'm a steward of oceans, rivers, and earth. I'm taking members if anyone wants to join me. I'm just adding to the many abbreviations that we have in our stormwater world. So let's just jump right on in. September 8th, that new permit for the construction general permit was adopted. So now what do we all need to know? Well, I'm bringing up some topics. What matters? Well, what matters is TMDLs. What are those? We're going to find out. I'm sure some of us already know, but we're going to go dig a little deeper on what they mean with the new permit. Trash requirements, passive treatment, sampling, monitoring, dewatering, and we're going to finish with post-construction plans. New stuff in the permit. All right. So I want to start too with just some important dates. We do have a new permit. So when does it all kick in? Well, it's not going to be until next year, the effective date of the new permit, September 1st, 2023. That means if you get a WDID number after that date, you will be complying with the new permit. If you get a WDID number issued before that date, then you will be complying with the 2009 old permit all the way up until September 1st, 2025. They'll give you to get used to that new permit. So after September 1st, 2025, we'll all be in the new world with our new permit here. And then we're going to begin the new permit part of the show with what is a TMDL? Well, if you're new to the stormwater world or you've been in here, you know we love our abbreviations and acronyms. So TMDL means, of course, too many darn letters is what we got to remember, and everything has an acronym or abbreviation. But TMDL, it means total maximum daily load. Now, how can we just show this easily to some people that might not really grasp the idea of what a total maximum daily load is? Let's pretend we have a river. I'm actually doing this presentation in Petaluma, so I'll kind of theme some of my rivers and stuff to stuff around here. This is about rivers and flowing into the ocean. So let's pretend this is our Napa River right here. And We have sources of pollutants coming from agricultural, natural, industry, residential impact. Well, with the new construction general permit, we're adding construction right there into it as one of the polluters going into this Napa River. So how do we get a TMDL? Well, we get some highly trained scientists to get on the case. And they can spend anywhere from 4 to 6 years analyzing the river, seeing its beneficial uses, seeing who's polluting it, what pollutants are going in there, and then they realize a certain level that this river can accept. That's going to be your total maximum daily load. That's going to be what you as a construction site can put into that river to keep its beneficial uses going. So what does that mean as you as a SWIP QSD? Well, that means that when you're creating your SWIP, you're going to have to find out if you're a responsible discharger. How do you find out if you're a responsible discharger? Table H. Table H in the new permit will go over all the TMDLs in the water bodies that you're working around. If you're in region 5, you know who cares about TMDLs? The fish. So our little friend, the fish, is going to stick in on this part of the presentation because he's very interested in this. So if you're region 5, you actually don't have any TMDLs to worry about right now. So you're all good. I'm in Petaluma over here. So I'm looking at region 2. Napa River has a sediment TMDL. So I found out, yeah, my construction site's on the Napa River. I'm discharging right into it. I'm a responsible discharger. The TMDL is sediment. What does that mean? The new permit, it'll explain for you. You look for which constituent that you're discharging into there. We're doing sediment. So to comply with this new permit, you're going to have to do Russell 2 modeling. You're going to have to show that the BMPs that you're putting in on your site are going to bring your waste load allocation number. Each of these rivers have one. It's this little sheet right on the right. After you do your modeling, that number pops out. It needs to be below this tons per year. Here comes our fish again. You can't keep him away. He's excited about these new TMDLs. And what that means is waste load allocation number. I went to look for the Napa River. It wasn't here in table H3. They had a little side note that said, go look at the fact sheet if you want to find out if your river. So I did. And what the fact sheet told me was Napa River has a TMDL of 500 tons per year. So why wasn't it over here in table H? Well, they say that's the current natural load of construction sites anyway. So what they're saying is if you comply with this permit the way it's written, you're going to comply with that TMDL. So it was easy for that one. But other ones, you might have to comply with the waste load allocation number that's different. And that means extra sampling, extra BMPs to bring your numbers down. All right, and that was it for TMDLs. That's a big thing going on, but again, this is only those TMDLs are only going to be for responsible dischargers. So you might be in an area where there are no TMDLs, and you're going to be okay. The next one, trash requirement. This one, they don't have a lot of information in this new one, but what they're showing is they're piggybacking off the trash order that was given to municipalities, given to Caltrans and some industrial areas. And what it basically says is you can't let anything smaller than a cigarette butt. That's why I put this graphic here, even though it's the #1 item found in California, but nothing small, nothing larger than 5 millimeter cigarette butt can leave your site. So what does that mean? Are we going to be installing full capture systems in our sites? I'm not sure where the permit's going with this, but we're going to have to limit any trash from leaving the site. Not similar to the order that municipalities have to follow. They have to do monitoring requirements, track 1 or track 2. I haven't seen those yet in the new permit, but it's something to keep an eye on. Passive treatment technologies. These are also going to be fortified in the new permit. The way things have been going, they're trying to change it up. So what that means for all of you that are using passive treatment, a little overview, what you're basically passive treatment is you're putting chemicals in the water, they're binding to the soil, the sediment, and then they're weighing it down. You're left with clean water. Hopefully that clean water gets sent downstream. But what's been finding out is that water being sent downstream is having some problems with fish gills. It's causing trouble. So what are they doing? We're removing cationic chemicals. They're not authorized in this new permit unless they're being used in an ATS system. Anionic chemicals are authorized, but if you're using these, you're going to have to come up with a passive treatment plan. The QSD is going to have to create this plan. Engineer is going to have to design your outfall area with dissipation devices, so when you're discharging water, we're not causing more impairments. Another big thing, going over to NONA, if you're in the industrial world, you might be familiar with notices of non-applicability. Well, it's coming to the CGP world. And what it basically means is, if you can prove it, it's no CGP for me. And what you're trying to prove is you're going to have to get a certified hydrologist to come and prove that your site does not discharge into a water of the United States. And if you can prove that you're not discharging into any of those types of nexuses, then you can apply for a NONA. And then what that means is you'll get issued a WDID number, but you will not need to follow the permit guidelines. All right, and now sampling and monitoring. So these were some big changes came, and as a QSD, these are big changes for me. This is going to be big changes for the client. This is going to be big changes for everyone. So what's going on? Well, they're trying to limit those frequent flyer miles by the QSD, or they're not limiting it, they're actually going to maybe increase it, and they're trying to prevent QSDs not living next to their projects. So what does that mean? Well, they're going to make the QSD have a lot more trips to the project. They're going to require it twice annually. They're going to require it after an NAL exceedance. Each phase change, they're going to require the QSD to come out. And anytime one is replaced, that new one's going to have to come out to the project. So they're just trying to limit QSDs not living close to the project and more hands-on, because I agree, the more everyone is hands-on with the project, the better your compliance options will be, because you're only as good as your QSD, and that's important that they live nearby. So this was a great snippet. I watched the presentation yesterday with John and Rosenbaum, and I snipped this actually from that presentation. I hope it's okay. But this is kind of the rules and who can perform certain inspections. So it kind of shows you which ones the qualified SWIP developer could do, the QSP, and a trained delegate. So a little confusion I saw on this was in the permit, it said a QSD needed to visit the site after an NAL exceedance, but then this one right here says a QSP can also be that person doing the inspection. I don't know if it's a both or an individual. Again, we're all still trying to digest this permit together. So this little chart kind of gives a good way to look at what you might be entitled to be doing. And if you look closely, you can see that pre-precipitation events have to be done by a QSP. So that's going to be one event that we're going to have to keep an eye on that can't be used by a trained delegate. And what does all this mean with more involvement with QSDs and QSPs? Well, it means no more REAPs. So we can all say goodbye to the REAP. I'm sure we all loved filling out the REAP. It was kind of shown that it might not have been the most useful document. So we can pretend that we're removing it, but what it's really doing is we're beefing up that pre-inspection, and we're just kind of creating one document to help it, because now only a QSP or QSD can perform that pre-inspection, similar to a REAP where you had to be a QSP. So even though there's no more REAPs, it's now in your pre-inspection. And here was the big one, qualifying precipitation event, a new abbreviation to remember, QPE. And what's the big change? Well, it's based on forecast and not just on accumulation. So this is going to be pretty big right now. It's going to make planning, it's going to make scheduling your inspectors, I think, a lot easier. We can read this definition. Qualifying precipitation event is any weather pattern forecast to have 50% greater probability of precipitation. POP, P-O-P, abbreviation acronym. Not sure which stormwater professionals are going to use going forward. But then you also have the quantitative precipitation forecast of 0.5 inches or more. So what does all this mean? Let's try breaking it down in a calendar so we can see it with our eyes. Okay, so here's the NOAA forecast table. This is where the permit wants you to look This is where they want your eyes to go when you're forecasting those rain events. So as we can see, these first 2 days, Monday and Tuesday, this isn't real world data. Monday and Tuesday is, but I changed other data to make this presentation work. So Monday, Tuesday, we look at Monday, we get our first thing, 50%, yes. We calculate all the precipitation in that day and we're over 14, 24, 3, 10, we're over a half an inch of rain. What does that mean? We have a qualified rain event. It started on Monday. So if you saw that information on Friday, you're scheduling, or Sunday even, you're scheduling inspectors now for that Monday. A big thing I know we're gonna have to figure out is what if you wake up Monday morning and there was no rain event, now all of a sudden your totals went over half an inch. I'm not sure how we're gonna have to figure out sending inspectors then day of weather changes, but we'll have to figure that out. But anyway, we got our rain event. The next day, we have over 50%. And what's the rule to continue a rain event? You only need a 1/4 inch of rain forecasted. So we read our forecasted totals. We have 25.25, 1/4 inch of rain. That rain event is continuing. So here's where things get different. So the next 24 hours, I put it yellow in there, but you might as well look at that as red as well, because when we look at it, we reached our 50%, but when we add up our forecasted totals, we don't get to 0.25 inches of rain for that day, for that 24-hour period. So what does that mean? Well, no inspections are going to be required. Even though you're getting rain, back in the old permit, we'd be out there, it'd be drizzling, we'd be waiting for it, having to conduct inspections. But now we're doing it by forecast. We don't have a 1/4 inch of rain, no inspection needed. Next day, no 1/4 inch of rain, no inspection needed as well. Just to throw it on there too, they're increasing our hours for pre-inspections, which is great news too. It helps us schedule things a lot easier for us. 72 to 120 hours. I did the math for you. That's 3 to 5 days. 5 days out, you can start your pre-inspections for that pre-rain event. We go back to our calendar. We go to the next days. We're getting up some bigger totals, 0.15 inches of rain on Friday. But again, we're not at that 1/4 inch, so this would technically not be a storm water qualifying event to do an inspection. But then we got Sunday, we're back over that 1/2 inch of rain, back over that 50%. That's another rain event. Post inspections for that Monday, Tuesday rain event, I kind of came out of order there. You now also get 90 hours to get that, and that's 4 days. So now we have 4 days to do a post rain event. They're just giving us more time. This is great for all of us schedulers who are trying to figure out how to get all our inspectors to the sites for these multiple inspections. So that's kind of a breakdown of the new qualifying precipitation event. We got a new abbreviation to remember, but hopefully that made a little more sense. All right, dewatering. So we do have some more dewatering requirements. I heard them mentioned in yesterday's presentation, and we're going to bring them up again. So what's the permit doing? Well, it's kind of bringing everyone together. There's certain regions that have their own low threat, low discharge dewatering permits that you should be getting. But the permit's now making that across the board. So what does that mean? It's not just dewatering groundwater. This is going to be dewatering depressions, low spots, puddles, anything that you're dewatering with mechanical means. Rosenbaum yesterday said that was going to be mostly pumps is what they're talking about. So if you're doing pumps, you're going to have a dewatering plan. If you're dewatering your trenches after a rain, you're dewatering just any low spot, you're going to have your QSD come up with a plan for the specific dewatering procedure. And in that plan, they're going to have a map. They're going to have to show what BMPs are being used. And you're just going to be a lot of work to put in for these new dewatering procedures, something to just keep an eye on going forward. All right, post-construction plans. This one had a little heated debate on the adoption day in September, and the compromise is instead of needing your low impact development, your post-construction plans, what your swales are doing, what your basins are doing and everything, they want those plans at the beginning when you're submitting your SWIP. So they wanted full final plans, but they've negotiated to preliminary plans will be required to get a WDID number. They want them included with the SWIP. So that's a new change. And going forward, you're going to have to put that plan right there with your SWIP. So that's always good too. And that brings us out of what I thought was important with the new permit. Again, not only everything I thought, I could do a whole presentation on it, of course, but for right now, that's some main topics of the new permit. I recommend going out, reading it. These permits are lengthy and there's a lot of words to understand. So getting a head start right now is probably the best bet. So this section right here, in between each section, I kind of want to just bring it back, why we do what we do. It always changes for all of us. When I was in my 20s, it was whatever I wanted, you know. Now I have a little boy, so now all my focus is on what he needs, and that's why I do what I do. And the whole point of me doing this presentation is part of that, is I want to create a way where we all can work together, because finding a way to be in compliance, it takes a team. It takes regulators, it takes us consultants, it takes the client, the builder, and it's all of us working together, finding a solid plan and making it economically feasible for all of us. So that's what I strive to do in my work, and that's why I give presentations like this, so we all can, you know, have this collective energy of doing what works for each of our specific sites. All right, BMP 101. So this section's changed quite a few times. What I did was I kind of threw like a questionnaire out. I asked some of my colleagues just stuff that they see in the field that they thought was common sense, but they keep seeing it. So these are just collective ideas. Maybe to some of you, you're like, yeah, why are people still doing this? So I just kind of want to bring them out. But first, we're going to do a little acronym or abbreviation. So that's one thing I see in the field. A lot of people are kind of confused on what's an acronym and what's an abbreviation. Well, let's go through it right here with you today so we can solve it. SWIPy. Well, for one, it's an acronym, but we need to stop saying it, okay? It's not SWIPy, it's SWIP. I don't know if someone's just saying the P individually at the end or actually adding a Y. I'm confused myself when I hear it. It's SWIP. I even see SWIP plan, which is more understandable. I can see you're taking that P out of the word SWIP. Okay, SWIP, it's an acronym. BMP, what do we got? It's an abbreviation. SORI, that's me, I'm a SOAR. I'm a steward of ocean, rivers, and earth. That's an acronym. And QSD, abbreviation. So how do we know the difference between acronym and abbreviation for everyone going forward? If you say the word like SWIP, you're an acronym. If you're saying each individual letter, you're an abbreviation. All right, too much time spent on that. Let's go to our BMPs. Poor BMPs, what am I talking about? I'm talking about sad BMPs, of course. This one's lying on the side of the road. They're poor, okay? They're the poor waddle that never catch a break, only catches the steak, right? No, I'm not talking about the sad waddle on the side of the road. What I'm talking about, and like I somewhat mentioned earlier, you're only as good as your QSD. You're also only as good as your BMP installers. BMP installers can make or break a site. And that's because it can all look great on paper, but when you're installing it, things need to be done correctly. I recommend having your QSP be there with installers most of the time, or at least do a lot of training with your installers. It's required in the permit that the installers have training. And the more I go out there to look at things, the more I see that there's not a lot of training for installers. So we look at these two pictures. I'm going to start with the one on the left. What can we see? What's wrong with it? Well, there's a few things. One, it's not trenched in. Two, it's not staked. And just to top it all off, what happened? They did the overlap wrong. I'll tell you, it's better, I guess, than, I don't know, actually. People just do but that not overlap either. So how do we know it? You have to be the rain. So if we're trying to keep the rain on the right side of this waddle and not go in the street, you want to send the rain back to the hill. So that's how you work with overlap. Your overlap is sending the water back to where you want it to go, keeping it away from the road. As you can see with these wattles, the raindrop's actually being sent into the road once it follows this wattle, and then it gets directed right into the road under the wattle as well, because it's not staked in. And that's what happens on the other side. So let's see on the other side of the picture, right? This wattle next to the fence. What's wrong with it? Pretty much everything that was wrong with our other picture, but one more fact. So one, it's not trenched. It's not staked. They're going right there, end to end. They're not overlapping. But what's the big thing is this wattle wasn't even needed. This whole site is a bucket. That curb actually is higher than most places. So there's no discharge actually going over the curb. That means the curb might be your BMP, which is perfectly fine. I recommend it. I'm not sure why more people don't use the curb. All you got to do, erosion sediment control plan, write it down. We're using the curb on that site. That's what we did with this. I talked to them. They're using the curb. You can remove the wattle. If this was done in the beginning, that's called money. That's saving energy and time. And that's how we do environmental compliance, is when we can put all that together. We're saving money. We have a plan that works. We're saving the environment. So that's the idea, is if you act now and you're educated and you're trained, then you can not make mistakes like this, and we're saving time in the long run. I didn't think this was a big debate, but 3x6 angular rock, everyone, for stabilized construction entrances. I see so many times little pebbles being used, little rocks or gravel. We need 3x6 angular rock. How do I know that? Well, this is another long lost book that I see that a lot of people don't read, is the CASCA guidelines. I feel that every BMP installer should have these CASCA guidelines printed in the back of their work vehicle. And what it explains is, it explains to a T exactly how each BMP should be installed, where it should go. It says use 3x6. It says make it 50 feet if you can, make it 10 feet wide minimum. And every once in a while, you got to refresh that rock, because then it just becomes another flat driving surface. Always always street sweep as well. Sometimes these aren't good alone. A lot of people, even though they're expensive, think you can just use the stabilized construction entrance. It's one of the BMPs in our playbook. Again, the CASCA guideline book, I also agree that all QSPs, all trained delegates, QSDs, we should always be reading that book. Again, most construction sites have the same BMP, so you don't have to read every single BMP, but it'll tell you a lot of important information. It'll make your QSPs smarter with inspecting. Here we go. Slope failure. So what happened here? Was it the wrong BMPs? We have blanket put on all the slope. We have the silt fence at the bottom. What went wrong here? Sometimes it's hard to tell what went wrong. A lot of the times it's easy. Well, here it could be a number of things. One, I could blame the compaction, the guy who engineered this slope. Maybe the compaction was wrong, and even though you put BMPs, raindrops still find a way in there. Here, I noticed no wattle at top of slope. That right there would have directed some of this water away from this slope and prevented a lot of this erosion. Silt fence at the bottom, CASCA guideline, don't put it right at the toe of slope. Put it offset if you can. If you got a river right there, do it. But also silt fence, more efficient away from the toe of slope. So here, you never know. It could just be compaction. It could be BMPs, but sometimes there's failures that you just realize you have to regroup and create a better plan. And that's no problem with that either. We can agree that we all make mistakes. All right, here's a good one too. So the CASCA guidelines, I will always recommend them. And that's part of training. That's part of forward planning. If your BMP installers know how to install BMPs, they're going to save your project. The best inspectors I've had used to be BMP installers, because once you know how to install them, they're way easier to inspect. You feel more confident inspecting them. But we always run into problems like this too, where if you read those CASCA guidelines, it would tell you silt fence to silt fence. You got to wrap them up together and they need to be continuous. And this is where forward planning is. This is knowing how long your rolls are, knowing where your low spots are. Be the rain. Where is it going to flow? Where is it going to be? And even after a rain event and you have failures like this isn't just a failure. This is a learning experience. This is, we now know low spot here. We're going to have to put some extra maybe fiber rolls to dissipate some of that water flow, because a lot of it's being concentrated to this area and destroying the BMPs that are currently there. So again, training, forward planning, be the raindrop, not only as an inspector, but also as an installer, because we're only as good as our trifecta, our QSD, our QSP, and our installers. That's the line of what we need to follow. And here it is. Here's a big one too. Silt fence with fiber roll put right on next to it. This is one of those big no-nos, but they just keep doing it. I don't know if it's BMP installers just making more money, or people actually thinking you're getting double the protection, but it's been proven that this whole double stack thing doesn't really work. You look in the CASCA guidelines, nowhere does it say that you should be putting fiber roll right up onto your silt fence. So if you're a developer and you're watching this and your QSD or QSP is telling you, let's put silt fence and wallow right next to each other and go around your 600-acre property because we're going to get extra protection, just be like, you know, let's talk about this a little further. All right, and that was the end of the BMP section there. Again, why we do this, just I like to take a pause every once in a while, and the way we make environmental compliance work is us all working together. That's the developer, that's us consultants, and that's the regulators. We all need to create plans that work effectively for all of us, and that's why we do this. That's why we hold these presentations, have these topics, to find better ways to improve the way we do things, so that going forward, we're not wasting energy, we're not wasting time. More importantly, we're not wasting money. And when we do those things and protect the environment, that's how we all win. And that's what we all are striving to do. So I'm glad all of you participants in here, you're already taking that step to working together to find common ground to help combat some of these issues that we're all facing. Okay, and now this brings us into our new technologies in stormwater. I had my colleague Jeremiah put up together a little video. I've always been interested in using drones for inspections, and I kind of said, can you put together on how we use UAV for stormwater inspections? And here's a video that I'd like to show you that he put together for this presentation.
UAVs, or drones, have become widely used in today's society. Every day, new innovations are being made with drones at the forefront. They are quickly spreading to touch every industry, including those with a focus in stormwater. My name is Jeremiah Wilson. I am Condor Earth's GIS analyst and licensed UAV pilot, and I am here to educate you about how we use drones to enhance site inspections with a focus on stormwater. When it comes to inspecting a large site, there can be many factors that may prove challenging to complete on foot. Some of these factors can be heat or other adverse weather conditions, potential site hazards, active construction or heavy machinery operations, or unknown site characteristics that could pose a risk to our waterways. Utilizing a UAV, personnel conducting an inspection can gather highly detailed site information from a safe location or to reduce the need for future return trips to the site. By doing this, they can focus on more critical items on their inspection list, such as inspecting BMPs, auditing failed stormwater control measures, educating site personnel about stormwater management, or strategizing with site personnel on how to implement best management practices. At Condor, we utilize high-accuracy GPS and ground control tiles that are visible from the air. This way, UAVs can gather very dense elevation data that can be used to enhance inspections. As you can see here, this point cloud was gathered using photogrammetry and thousands of images taken over a pre-programmed flight. The point cloud was then cleaned to show only ground and structures that would contribute to stormwater runoff, then transformed into a high-resolution digital elevation model. The creation of this elevation data is done through triangulating a network of points, then compressing it to a 2.5D image representing site topography. What you are seeing now is the resulting high-resolution digital elevation model from the point cloud shown earlier. This model can be used as the input for many analyses focusing on stormwater management. Using hydrologic spatial analyses, we were able to determine drainage areas for the site you see now for use in their stormwater control measures across the facility. Other products of this data can be volumetric estimates of site or storage capacity and modeling containment improvements to mitigate off-site discharge. I've already covered many of the pros about using a UAV for site inspections, but there are a couple more you should be aware of. What you're seeing now are some examples of sites where a UAV may better serve the site inspection than simply walking the site on foot. As you can see, extremely detailed models can be generated like this one. This model is of a spillway that was created using a UAV. Personnel are able to pan, rotate, zoom in and out, and inspect the model without needing to go into a potentially dangerous area. This is an example of an orthophoto generated using a UAV. It shows the level of detail one can achieve and again highlights why personnel can reduce return visits to the site. Now let's talk about some cons. One of the biggest is that UAV licensed pilots aren't allowed to fly over humans or vehicles not actively participating in the operation. However, as you're seeing now, these are the FAA's exceptions to that rule. The first exception, Category 1, is simple. You only need a UAV that weighs half a pound or less and has no exposed rotating parts. This generally means installing propeller guards on most drones. Categories 2, 3, and 4 require additional conditions be met, and there are currently no drones approved by the FAA that meet these criteria. However, waivers can still be obtained through the FAA for operations over people. Hopefully, you now have a better understanding of how UAVs can help protect our waterways. Thank you, and enjoy the rest of the seminar.
All right. And I want to say thanks again to Jeremiah for making that for me. And just to kind of go off what he was saying there is UAVs, they're not going to be meant for every inspection site. You got your small construction sites of residential homes. It doesn't replace walking on the ground and looking at stormwater control measures that you need to be on foot. But for larger sites, for your 500-acre sites where you have silt fence surrounding the entire thing, flying that and looking for damage is going to be so much easier than driving or walking if you can't drive. So areas like that where it says you can't fly over human beings, that's a problem too for these inspections. But to get around that, you sometimes just time of day is important. So if you go to a time of day where there's no one outside or no one's at the site, then you can usually fly easily around that. But again, always look at those regulations because those are important to follow going forward as drones are just being used more and more in every industry, it seems like. All right, and then the next technology that I wanted to talk about is for on-land visual trash assessments. So if you're a municipality, if you're industrial, or if you're Caltrans, you have these new on-land visual trash assessments. What that is the new trash order that went through is that you have to choose two different tracks, track 1 or track 2. And track 1, full capture systems in your storm drain. Track 2, showing that what you're doing is equivalent to that full capturing system. So I brought this in too because the trash requirement in the construction general permit was kind of piggybacking off this order, and it's the whole 5 millimeter size, nothing in the drain. So, but without the monitoring requirements, and that's for the permit. So if you're a municipality, if you're an industrial or Caltrans, you need to do the monitoring. And what does that entail? Well, it usually entails these OVTA forms where you have a small section of map right here, you're putting lines, you're walking it with 2 inspectors, you're giving graded letters A, B, C, D of not littered, slightly littered, and you're creating this data assessment of trash in your area. So why is that important? Well, if you can prove that you don't need a full capturing system in a certain area because trash isn't a problem, well, you need to prove that with data. And that's what these visual assessment forms do. And that's what they help us figure out. So then when you are putting in those full capturing systems, you're saving money and time because you're only putting them where they're needed, or you're doing other things to help prevent it, and you're doing something equivalent. So then you don't need to do the full capturing system. But what the problem is these forms are cumbersome. You're going to have to go through hundreds of these if you're a municipality to figure out where your trash problems are. So what was my whole why we do this? We do this to bring in new technology to make our lives easier, more efficient, bringing costs down, but also not just bringing costs down. We're not bringing the quality of work down. We're just making it easier to do the work. So what's been created, we're on the forefront at Condor, and I'm sure this will be going everywhere, is it's this automated and streamlined data website that you can visit. You can go, you can take your assessment forms, you can put in the data into this website, and what it's going to do is it's going to create a living map for you. And this living map is something that a municipality can log into, and it's going to have all the data right there for you in a nice way to present it. Because the problem is we get all this data, but if we can't present it in a correct way, we're not going to use it efficiently. So what we're doing is we're taking all those assessments and we're plugging them into this interactive map. So now if you're going out and you're creating these forms, you're going back, we're highlighting the data and figuring out what it means. So what does it mean and what we're worried about? Here, this is one of the interactive maps. You can show your inspection records. You would click on one of these lines. It's purple for a reason, color coded to what kind of trash was found there. It tells you when it was inspected, who it was inspected by, and what they found there and what grade it received. And this is all logged in the database, which then can be turned into graphs. It can be turned into any useful information that you're then presenting to show that you won't need a full capturing system because what you're doing is equivalent to removing that trash from your streets. And the first way you can do that is having these assessments and knowing where the trash is. So this live map just kind of brings all that data together. But it only just doesn't talk about where the trash is. What this data also we can bring is it can show you which storm drains are impacted. And then with that data, you can send your maintenance crews to go clean specific storm drains that have been impacted because these assessments, you're already out there. So data we're gathering, you would click on the map. It shows you where all the drain inlets are. You'll be able to use this GIS data to compare with maps in your own place of business to see that these storm drains are accurate. We click on a storm drain and it will show you a picture of the storm drain. It'll tell you, is it impacted? No. Another requirement of municipalities is you must have signage on all your storm drains. So this program also shows you right there, has it have signage? It doesn't. So that'll also help save time and energy because now municipalities can send people directly to specific areas to figure out where there's no signage and where it's needed. Going a little deeper, you can see where illegal dumping is occurring. These little hot spots get shown on there, and then you can click on it. Not only that, it'll show you a picture of the illegal dump. And then again, it's just helping the maintenance crews or whoever is picking up this stuff go directly to where it is, and they're not just wasting time trying to find it because it's already been logged and recorded. And the perfect thing about this is, at first, how are we going to save more time and be more efficient? Well, instead of taking all those forms and all that paperwork, well, we now have an app and you can do it right there in the field. You can put it on your phone, put it on your tablet, you can log in, and now you can do everything directly from an app. And now all this data, we're removing the paper, we're now creating this whole living map right in real time while the inspector's on the ground. And that's going to be huge. And it's just a new way to just show the data collected in a way that now can be used by a municipality, Caltrans, to help focus their energy on a specific area. This was the app playing here. You can zoom in, you can create the lines yourself, you can say what trash level it is, and all this data gets stored. It can then be logged in later, and then you can now use it to whatever means you need to figure out how to control a trash problem in your area. So that's just new technology in the OVTA world. If that's something that you're in, this is something you really want to get looking into, because it's just going to streamline a whole bunch of efforts down the road. All right. So now we're switching from technology, those technologies, good ones, back to sampling 101. Why did I want to end with sampling? It was kind of a last minute addition because of all the new sampling that was required of the permit. I'm going to go pretty quick here. But first, be aware of your surroundings. There could be sharks in the water, so be careful where you're sampling and make sure that it's a safe area. If not, then get out of there. But we start off, I recommend the Stormwater Sampling a Field Guide by the State Water Resource Control Board. Great video. Go YouTube it. This is great training for all your staff. Have them watch it. Important stuff. Good job, Water Board, on this video. All right. So you're the sampler. Let's prepare for our sampling. You're going to want to review requirements, contact your lab, train personnel, and locate equipment. So what does that mean? Well, your SWIP or someone else should have created a monitoring sampling plan. You're only as good as your plan that you're following. So this plan needs to show, why do we sample? We're discharging to an impaired water body. It should say that. What do we sample for? Napa River, sampling for sediment. Okay, where do we sample? Discharge location. This should all be in that plan. When do we sample? That's a big one. It's different for industrial and different for construction. So knowing those times is important. And how do we sample? Is it with a turbidity meter? Is we sending bottles to the lab? Might be a lot of new ideas with the new TMDL requirements. So this is going to be important stuff to know. So if you're not used to contacting a laboratory, well, let's get used to it, okay? Saul Laboratories is there. You better call Saul, because he's there to help you. And if you go to a lab, they're going to help you. You're going to come in, say, I have these constituents. They're going to be like, you need these bottles. You're going to need to sample it in this. It's going to need to be in a cooler. Fill out your chain of custody. That's just basically saying when you sampled and the chain of when your sample went to the lab. It's just kind of documenting that whole process. So those are important documents to have. Just contact them and inspect bottle integrity from receipt from lab. Training, this is huge. Delegate responsibility prior to rain season. Your sampler should be able to answer that what, when, where, and how, and train alternates, because it's rain season. People get sick, so always have an alternate. And always know who's going to be sampling. Those 24-hour industrial facilities, you have 4 hours from that first time of discharge. So you might have to sample 3 in the morning. So who's on site at 3 in the morning? Well, hopefully they have a good plan to read and that they'll be able to sample for you. All right. My big pro tip with gathering your equipment is organize your sampling kit. An organized sampling kit will go a long way when it's pouring rain and you just don't know what's going on. Having an organized sampling equipment with all your stuff in there will make your life a whole lot easier. All right, glass versus plastic. Is there a difference? Well, they're easy. Why not use plastic everywhere? They don't break. You can store them easily without breaking. So why not? Well, Glass has its many uses. Oil and grease can't be kept in a plastic bottle. It must go in these amber bottles or glass. Amber is used just for the sun. They don't want damaging some certain preservatives. So there is a big difference between glass and plastic. Sampling tip, don't assume they're all created equal. Like I said, these bottles could be damaged, so make sure you got good ones. Preserved bottles, well, what does that mean? Preservatives in the bottle. Basically, when you're pouring your sample in there, that preservative is freezing it in time, and it's helping it stay solid until, not technically solid, but it's helping it stay preserved until it gets to the lab, because usually those are, a couple hours down the road. So these preservatives can be harmful. Keep them cold, do not overfill, and get them to the lab. So sampling in the field, again, always be aware of your surroundings. You never know what might come out and get you, okay? Watch out, there are dinosaurs in the field, so be careful when you're sampling and keep your eyes up. So what are we doing when we're sampling in it, okay? We're transporting from a sampling location to laboratory for analysis without contaminating it yourself. How do you do that? Aware of your surroundings, clean sampling techniques, being methodical, always asking the question, what am I going to do to adversely affect my sample? Pop quiz. What's he doing here? He doesn't have gloves on. Uh-oh. So what is clean sampling technique? Well, always wear clean gloves. Very important. Protects the sample, protects the sampler. And when in doubt, throw it out. Don't touch the rims. Don't put caps on the ground. Because any detection above that regulatory limit will just cost money and extra work. And what are we all about? We're about being efficient, being things not costing more money and not doing extra work, just doing them right the first time. And that means decon. That means decontaminating your equipment. Anything that you're using on multiple sites, multiple times in the day, should go through these 3 5-gallon buckets. You got your soap, rinse 1 and rinse 2. That'll help keep your equipment nice and clean for the rest of the samples. So here's your typical industrial sampling. You got your facility discharge drainage. You got your surface drainage. Where do I sample? Well, the storm drain that's going to the city. That's going to be your discharge location for this site. And that's where you're going to want to collect your sample. You're going to collect it. You're going to store it, keep it cool. It needs ice. Bag your samples, bag your ice, keep everything cool at what it needs to be. And then what is it? Get it to the lab. Have it labeled in its ice, follow that, and go to the lab. And with that, I'd like to go to our final thought of our presentation, which is, again, as this whole stormwater week, rivers into the ocean, how do we all work together to stay in compliance and keep our beneficial uses in our rivers and streams? Well, it's working, again, with that trifecta, the developer, the consultant, and the regulator. It's all of us working together. It's all of us talking. It's all of us finding new ways to improve the way we do things going forward so it benefits everyone. I want to say thank you, and that was the presentation.
All right, well, thank you, Scott. So what I'd like to do is, we just got a few minutes left. We have a few questions and a couple comments. Someone pointed out that when you were talking about the sediment TMDLs using the Russell 2 model, you're also showing, you must also show less than the pre-existing sediment loss, not just the waste load allocations. And so you're going to need to use that Russell 2 modeling tool, which can be downloaded from a couple different sources. I think the Water Board will have a link to that. And then there was also a comment about the QSD not needing to necessarily be close to the project, although that might be pragmatic. The whole point of the permit, this commenter said, was that there'd be more oversight and more engagement with those on the site. Being close physically, geographically, the site obviously makes sense, but the point of the permit was more to have that greater level of engagement. Let's see, though, we did have a question for you, though, here. Is there a regulation or instruction for handling construction site spoil piles, or sometimes called stockpiles? And how can it be stored on site? If it's clean, can it be spread out and applied anywhere? What do you think there, Scott?
So they have a stockpile of topsoil. Is that what I'm assuming?
No, they didn't specify just stockpile. They said spoil pile, but you bring up a good point. This permit talks about topsoil.
Mm-hmm. Correct. So they want to preserve all the topsoil as much as you can. So if it is topsoil, I would say, yeah, berm it, protect it, so then it can be used back on your site. If it's waste pile, I would make sure we know what's in it. If it's just regular dirt, definitely you can usually protect those. But then if you're going to spread it on your site, that's the best way, so you don't have to truck it out. But if there's any pollutants in it, that's going to be a whole different story.
Yeah. Okay, and I'm just going through these quickly because we just have a few minutes left. All right, people like that drone video. Are municipalities using the drones? This person's from Texas, so they kind of want to get a feel for what's going on here in California with drones.
Yeah, I mean, I wouldn't say they're technically using them, but when they hire a consultant like us, we find ways to make things more efficient. So if we're working for a municipality, we could just say, I don't know, groundwater sampling, that's more GIS data. But if there was a reason to use it, then definitely we would use it with municipalities.
All right, good. Okay, three-part question regarding the new CGP and precipitation forecast. The new permit states qualifying precipitation event is any weather pattern that is forecast to have 50% or greater probability of precipitation, and a quantitative precipitation forecast of a ½ inch or more within a 24-hour period. The event begins with the 24-hour period when 0.5 inches has been forecasted and continues for subsequent 24-hour periods when a ½ inch of rain is received, or I'm sorry, is forecasted, not received. Is there a specific or does it get specific in the permit regarding the source of the forecast?
It does, and I think the permit's always the NOAA.
Right, exactly. Question number 2, do you have any comments or recommendations regarding acceptable forecast sources? And again, that's going to be, it is very specific. You can only use one, and you showed it on the screen.
Mm-hmm, correct.
In fact, if someone's listening, can look that up real quick and throw that into the chat, the link. Mm-hmm. And then another question, is there any new information about how the forecast should be documented? Well, I think you showed a really good example. That's exactly what they're wanting to be done.
But that was my question too, was what if I wake up and the whole forecast changed, Do I have to regroup is it 24 hours before the rain event and that's the forecast you're using, or do you have to change your whole plan when you wake up that morning?
Yeah,
that's going to be a big question.
That would be my read on it, is once we lose that 24-hour period, it's not a 24-hour forecast. Mm-hmm. So yeah, it's typical for a forecast to go way up even hours before it. Thank you, Kara. You put that weather link in there. All right. Well, I think we're just about at the end of our time. Scott, you got your contact information up there, so if people would like to continue the dialogue, I'm sure you're available to do that.
Oh, please. I recommend it.
All right. And we have lots of other workshops coming your way this week. So hope you can take advantage of it. So thank you for attending, everyone. Thank you, Scott. Fascinating presentation. I love the humor. So thank you very much.
All right. Thanks, everyone.